fraction. It means I have a fraction inside of a fraction. So they're going to multiply the bottom by e and the top by e. So I get e squared over e plus 1. Simple enough? Ready for another one? Okay, find what this series converges to. I would like to point out that it doesn't because it's not geometric. Divide by 8. Divide by 8. Divide by 4. Do you see how they're tricky? Because it kind of makes sense, right?
Yeah.
Yeah? So you gotta check. It's pretty rude. But you only have 3 of those on your test.
So you check by dividing by the second number?
Well, you just find your A and your R, right? So, not too bad. Yeah? Okay.
What are these called?
These are geometric sequences in series. Let's make this a 1 over 8. Actually, let's make this not suck. 64, 32, 16, 8, and 4, etc. I want you to find S sub 10. Now we could go out 10 times and then add them all together and it would give us the right answer. Or we could take our A, take our R, take our N, and get it in one step. Is that okay? 2 to the 10, I don't have a clue. Does anyone have a calculator on them? I did not.
1024.
What?
1024.
Oh, of course.
You can calculate it.
It's okay, you don't have to, right? So far, so good? 64 minus 1, 0, 2, 3 over 1, 0, 2, 4 times and negative 2 over 1. Is that okay? And then you would just reduce, but I didn't bring my calculator, which I really should have. Actually, I can't find it. What's 1024 divided by 64 divided by 2? Or 128? Nobody knows? 2, 4, 8, 16, 32, 64, 6, 127.8. Do you have a calculator? Can I borrow it? Because I need a fraction. I need to know what 2 times 64 divided by. Okay. 1023 over 8. This would be the answer. Is that okay? Yeah? Okay, I think we should do a Taylor polynomial. Oh, have I done?
If you were to plug that into a converging formula, like it comes out pretty much the same, right?
No. Well, if n is big, it'll be close. Josh?
Okay. Are they ever going to give us that funky E thing? The Greek E?
Oh, yeah. I'm sorry.
Are they going to give us that on the test and be like, okay, figure it out?
Yeah.
Because I don't know how to.
Let me help you. Let's do it.
Translate.
Let's do it.
Sigma.
Let's do it. Okay. It'll just say evaluate. It's actually a Greek letter. You're right. Evaluate.
You want to learn Latin?
I equals 0. Let's say 8. Let's say a half. I, and let's go 4. Okay. We are going to use the formula A r to the n minus 1 over r minus 1. So we need to figure out what A is. What's my A?
8.
Very that it says n minus 1 on top. So if you want n, you're going to have to plug plus 1 to the top number. That's okay? It's always one more than the top
So
number.
if I equals 1,
When you started, then that would be a shift in index, and I don't think you're ever going to see that.
so it'll always be 0 on the bottom. So you basically just add 1.
So the view has it. Oh yeah. Yeah. First up, okay.
So far, so good? Does everyone understand where the 5 came from? That's the part most people miss. Yeah?
Great.
No? Just add 1 to the number on top, and that's your n. Is that okay?
Do we, just a quick question, do we add 1 just because we don't want to take into account the 8? Is that why? Do you know why we add the 1 after?
Yeah. If I go, first term is when I plug in 0, second term is when I plug in 1, 2, 3, 4, so there are 5 actual
Oh.
terms. So, I would have 8, 1 to the 5th, 2 to the 5th, 2, 4, 8, 16, 32.
Yeah. Like basically what they're saying in the summation is take the sum of the series
So this
from
would be
0 to
8
whatever
times negative 31 over 32
That's why
times
it says like SN.
negative 2 over 1.
Is that how you're tracking 0?
What?
Okay, got it. Yeah.
I have no idea what you're talking about. 2 would cancel out with this to be 16. Cancel out with that to be 2. So I get 31 halves. What? Okay, ready for we need to do a Taylor polynomial and then a fence problem. And I think we've done everything. Can you think of anything we haven't done? Okay. Let's do a Taylor polynomial.
So we have
I'm just going to put this up. Oh. I don't think it's counted there, right? And then I'm going to do the Taylor polynomial. I see this Taylor polynomial a lot.
I have a phone, so you can't log in, so
Ten, ten, ten.
but yeah, she's pretty good.
Ah, cough, cough. Chuckle, chuckle.
Probably won't go to man this
Elbow, nudge, nudge, right? Okay. Find the 4th degree Taylor polynomial of f of x equals the cubic root centered at x equals 0. Okay,
Oh yeah.
here's how you do these. Whatever degree it tells you, that's how many derivatives you take.
That was when it was,
So?
like the absolute max.
My f of x is 1 plus x to the 1/3. My f prime of x is equal to 1/3, 1 plus x to the negative 2/3. My f double prime of x is equal to negative 2/9, 1 plus x to the negative 5/3. My f triple prime is equal to positive 10/27, 1 plus x to the negative 8/3. And my f fourth prime is equal to negative 80 over 81, 1 plus x to the negative 11/3. Now I know this looks gross, but it's actually really not too bad. The trick is, does everyone understand the derivatives? Did I go too fast? Now, sometimes they put a number in front of here. Usually they don't. But this would just be tacking it on the end because the derivative is the inside, right? Okay? So now what I do is whatever it's centered at is what I plug in to get part of my coefficients.